So guys, this is the question that I have selected for explaining this concept of hybridization and the shape of a molecule. Okay, so this pertains to the year question paper of the year 2017. So every year you are getting a question in this particular format, which you need to understand and comment about the hybridization, the shape, geometry. Yeah, that's it. Okay, so let's actually read this. Which of the following pairs of compounds are isoelectronic and isostructural? So isostructural is something that we know. If two compounds have same structure, you call it as isostructural, isn't it? Same structure, isostructural. Now, what is meant by isoelectronic? There are two schools of thought for this. See, the first school of thought says that isoelectronic simply means the total number of electrons in both of them, both compounds should be the same, right? So isoelectronic, the first school of thought is total number of electrons are same. In when you compare two molecules, if the total number of electrons in one molecule is equal to total number of electrons in the other molecule, you will say that both these molecules are isoelectronic. But yes, in many a times in the question papers, whenever they are asking a question, isoelectronic simply means total number of valence electrons are the same. So we'll just consider isoelectronic as the property where total number of valence electrons are the same. Okay, so isoelectronic, total number of valence electrons should be the same, and isostructural, it should have the same structure. Fine. Okay, so let's go to the first compound here, that is BeCl2. So BeCl2, the first point to do is, first part of this particular solution is to find out the number of valence electrons. They are just asking you which are the following are isoelectronic also. So we are supposed to find the total number of valence electrons in this particular compound. See, beryllium is having 2 plus 2, 4 electrons are there totally because its atomic number is 4. So on the outer shell there are 2 atoms, I mean electrons, plus chlorine is 7 plus 2, 7 plus 7 is 14. So that is equal to 16. Now once you get the total number of valence electrons, divide the total number of valence electrons by 8. Okay, divide the total number of valence electrons by 8 and the quotient of this particular division, what will I get out of if I do that? This is directly divisible. 2 is the quotient, isn't it? This quotient is the number of sigma bonds, or I can say bond pairs. Okay, sigma bonds. And there are no lone pair of electrons over here. There are no LP, that is lone pair of electrons. So if there are only 2 sigma bonds over here, my hybridization is sp, right? My hybridization is sp. So if my hybridization is sp, obviously my geometry is linear. Geometry is linear. Why it is linear? Because it is a standard thing. Because if any hybridization is sp, then the geometry is obviously linear. Shape can differ with respect to number of lone pair of electrons. Because of the lone pair bond pair repulsion, there will be a difference between the shape and geometry of a molecule. Geometry simply depends upon which hybridization this molecule is having, but the shape is actually dependent upon the number of bond pairs of electrons and number of lone pairs of electrons. But there are no lone pair of electrons over here, so my shape is also equal to linear. Yeah, so up to this much information you are supposed to gather whenever they give you a question from the topic of chemical bonding and molecular structures, and every year you are getting a question like this, isn't it? Right. Okay, so I could gather as much information possible about this particular compound. I just need to make this kind of a diagram here just for the sake of satisfaction. Okay, this is a linear compound BeClCl on both sides. To minimize the bond pair repulsion, which is the weakest, it is kept at a linear arrangement. Okay, fine. So let's go to the next compound here. See, in all the 4 options I know I have a compound that is XeF2, isn't it? Xenon difluoride. Right, so let us talk about XeF2 now. See, XeF2, total number of valence electrons is, this is 8, isn't it? Xenon, no, helium, neon, argon, krypton, xenon. So this is a noble gas. And this is fluorine. So this is 8 plus 7 2s are 14, isn't it? So that will be 22. Now, this is the total number of valence electrons. Total number of valence electrons divided by 8. 8 2s are 16. So this is 2 sigma bond. Quotient is 2. So therefore it is the number of sigma bonds. What is the remainder then? Remainder is obviously 6. isn't it? Now this remainder is supposed to be divided by 2. That is equal to 3. This is the number of lone pairs of electrons. What did I do now? I found out the total number of valence electrons. Total number of valence electrons divided by 8 gives me a quotient and a remainder. That quotient itself is the number of sigma bonds. Remainder divided by 2, not 8, divided by 2 gives me the number of lone pairs of electrons. Right? Fine. So this is 2 plus 3 is 5. So hybridization is equal to sp3d, obviously. So trigonal by pyramidal. Trigonal by pyramidal is supposed to be the geometry, but what is the shape? How will I find out the shape? For finding out the shape, I need to remember a chart. So let me show you what chart it is. Remember 2 sigma bond, 3 lone pair here. This is the chart you are supposed to remember. So it tells you about number of charge centers, geometry of electron pairs, okay, or we understand that. But if I tell you to remember, this is supposed to be remembered, and the third one is also you can remember this one and this one. Just remember these 2 columns, okay. These 2 columns can be remembered from your level, and that will be enough to solve all questions. So as I was telling you, if I check for sp3d, there are 3 lone pairs, so this is linear. Fine. If there are 3 lone pairs, then I have 2 bond pairs, obviously. And they have given an example of XCF2. So this third column and fourth column are supposed to be remembered by you at any cost. If you want to solve questions in the NEET exam, so some way or the other you are supposed to remember this column and this column, right? And that will be sufficient for you to solve all questions in the NEET exam. Because you can directly get the hybridization by any method. If you can use this half into v plus x plus a minus c, you get the hybridization. But how will you get the number of sigma bonds and number of lone pair of electrons? They can ask you that. They can ask that directly also. Find the number of lone pairs of electron in a compound XCF2. So you are supposed to do some method by which you are getting the number of lone pairs of electrons. See, half into v plus x plus a minus c will directly give you the hybridization. It will not give you the number of sigma bonds and number of lone pairs of electrons. Right, so that is a problem when you follow that particular direct formula. Okay, so by this particular method that I am telling you, you can directly get everything that is required for you. And if you remember this and this column, that is more than enough, more than sufficient, so as to get the shape of this particular molecule, isn't it? So XCF2 is linear in shape. So let us make the structure of XCF2 over there. Right, so as I was telling you, XCF2 has linear shape, XE. This is F, 3 lone pair, one of them will be here and the other one is here and the other one is also here. So this is the shape of XCF2, right? So let us go to the next one. Okay, next one is TEI2. So let us take up this particular compound over there. So if I just start talking about tellurium iodide, so this is, okay, so what is tellurium? See, tellurium is coming under the family of oxygen. And iodine is coming under the family of fluorine, chlorine, bromine, iodine, isn't it? Halogens. So, right. Tellurium is oxygen, so this is 6. And 6 is the valence electrons here. Iodine, fluorine, chlorine, bromine, iodine. 7 2s are 14. So this is equal to 20. Total number of valence electron is 20. 20 divided by 8. What is the quotient then? 8 2s are 16. So 2 sigma bond. Remainder is 4. Divide the remainder by 2. You are going to get 2 lone pair of electrons. 2 sigma bond, 2 lone pair of electrons. Your hybridization is sp3. So the geometry is tetrahedral. But what is the shape? For the shape, you are supposed to remember that particular chart. So it is sp3 hybridized 2 lone pair of electrons. So let us check over here. So this is sp3 hybridization. And the number of lone pair of electrons is 2 over here, isn't it? And just see this particular example, water. Yes, exactly. So this is having a structure which is exactly similar to the water, isn't it? Water is O, H and H. There are 2 lone pair of electrons on oxygen. Similarly, here tellurium is the central atom. Remember, oxygen and tellurium, they fall under the same group, group 16. So this is called by the name of bent shape, or you can call it as V shape. Doesn't this look like an inverted V, isn't it? V. Now why is it not linear? Because of the lone pair bond pair repulsion. This lone pair bond pair repulsion will will push the bond pairs more closer, and this bond pair repulsion is overcome by the lone pair bond pair repulsion. We know this particular method is lone pair greater than lone pair bond pair greater than bond pair. Right. Okay, so let's proceed to the next compound now. This is IBr2 minus, isn't it? Fine, IBr2 minus. So the next compound is IBr2 minus. Here iodine and bromine come under the same category, halogens, isn't it? So 7 plus 7 plus 7, that is 21. Now this negative charge has to be considered, that is 1. So this will be 22. Total number of valence electron is 22. So 22 divided by 8. 8 2s are 16. So 2 sigma bonds. Remainder is 6, isn't it? 6 is to be divided by 2. So that means this is 3 lone pair of electrons. Total number of valence electrons divided by 8. Quotient is the number of sigma bonds. Remainder divided by 2 is the number of lone pair of electrons. So obviously 3 plus 2 is 5. Hybridization is sp3d. Right? So obviously the shape is, geometry is trigonal by pyramidal. Finally, there is one more thing to remember here. That is the geometry, shape. For shape, you are supposed to look at that chart here. So for the exam, at any cost, you are supposed to remember the chart. So 3 lone pair coming under sp3d. So that is exactly similar as XCF2, isn't it? Here also there are 3 lone pair, and this is sp3d hybridized, 2 sigma bond, 3 lone pair, and your structure will be linear. So shape is actually linear. Okay, so this is Br, and there is a bromine here also. Now 2 lone pairs are okay, and the third lone pair is there. Now it is because of one extra lone pair that iodine is having a negative charge, and your XCF2 is exactly similar to this, right? So this is one lone pair, this is another lone pair, and another lone pair. The point is, here there are 22 electrons, which are the outermost electrons or the valence electrons. In XCF2 there are again 22 electrons, because so point is, these two molecules are exactly similar in structure, in the number of valence electrons, in the hybridization that they have, and in the shape that they have. The number of sigma bonds are also similar, the number of lone pair of electrons are also similar. So actually these two are my answer. So yes, one more compound is there for us to discuss, isn't it? I think that is IF3. Okay, so IF3 can be discussed now. Okay, so yes, IF3. Iodine and fluorine come under the same halogen family, group 17. So this is 7 plus 21 is equal to 28. Valence electrons divided by 8 is 8 2s are 16, 8 3s are 24, isn't it? 3 sigma bonds, 2 lone pair of electrons, because remainder is 4 divided by 2, that is 2 lone pair of electrons. So this is sp3 dehybridized. And what is the shape then? Shape is actually, you can call it as T shape. So yeah, you can just refer to that particular chart. sp3 dehybridization, 2 lone pair of electrons. See, sp3 dehybridization, where is this sp3 dehybridization? Right, and 2 lone pair is T shape, ClF3, isn't it? So that is a good example that you can remember. They continuously ask ClF3 in one or the other tests that they give. So yes, this is T shape. So let us make this particular shape now. Iodine is the central atom, fluorine, this is fluorine, and this is also fluorine. So this is the T shape, 2 lone pair of electrons, right? So that is all. So we got our answer for our question. So as I was telling you, exactly similar is IBr2 minus and XCF2. So for this question, the answer that I will be marking is IBr2 minus and XCF2, isn't it? So the correct answer for this question is option 3. Right? So from here, the take home message is you can follow this particular method, because at one stretch, if you follow this particular method, total number of valence electrons divided by 8, this will give you the number of, the quotient is going to give you the number of sigma bonds. Remainder divided by 2 is the number of lone pairs of electrons. From there, you can calculate the hybridization, and if you know the hybridization, you will be remembering the geometry also, because for hybridization, for one hybridization, the geometry is the same, right? So geometry depends only on hybridization, but the shape is dependent on number of sigma bonds and number of lone pair. Why? Because that is dependent on the lone pair repulsion and lone pair repulsion. So yes, shape is actually coming after considering all these kind of repulsive forces over there, and for that particular matter, you are supposed to remember this particular chart that I have taken. Right here, SP. So here I have written all the hybridization over here on this side. So remember this particular hybridization, you make a chart on your own and you can stick it on the wall, and from here, from today onwards till the day of your exam, you can continuously revise this every day. Okay, so this particular column and this third and fourth column are supposed to be studied extremely well for the exam. Okay, you should not have any doubt in understanding the shape of a compound whenever they give you question in which the shape of a compound is demanded, right? So in SP you can have this option only, and there is linear geometry, that is obviously there. SP2 you have 2 possibilities, SP3 you have 3 possibilities, SP3D you have 1 2 3 4 possibilities, and SP3D2 you have 3 other possibilities which are also written over here. Fine. There was one other condition, that is SP3D3, so we are not going to that much detail over here. So yeah, I am restricting myself to this. Okay, so please make sure that you learn this particular chart. This first, third and fourth columns are supposed to be learned. Okay, so this is the geometry here. If it is SP3, then the geometry is only tetrahedral. If it is SP3D, the geometry is only trigonal bipyramidal. SP3D2 octahedral. Right, so this will be thorough as of now, isn't it? The shape can be a difficulty. So what you can simply remember is that you will have to remember these two columns for finding out the shape, and the shape can be found out with the help of the lone pair of electrons over here. So number of non-bonding pairs around the central atom is the number of lone pairs. So from that particular method by which we derive the number of lone pairs in a compound, you can simply just go through this particular chart so as to find the answer, that is which is the shape that is this particular compound is having. Okay, yeah. By the time you are solving a lot of questions before the exam, many of these common molecules which are written over here, many of these compounds, you will be directly remembering it by now. Okay, so for other compounds you will have to remember, you have to solve this particular method. And as personally speaking, I don't like this particular half into b plus x plus a minus c. This is something that I don't actually recommend you to follow. You can simply use this particular method that I have told you in this particular discussion in this particular video. Okay, so if you like this, please like, share and subscribe to my channel. Click the bell icon to receive notification whenever I upload a new video on YouTube. All the best for your NEET exam.